Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of GCSE higher level exam practice here with the Batty Boffin and Batilda the Batty Cat. Now today Batilda has got herself an algebraic fraction, and although she is a very mathematical cat, she's having a little trouble with this. So for part A of this question, could you please simplify this algebraic fraction, expressing it as one thing over some other thing with that simplified as much as possible? Okay, have a go at that now. Right, let's have a look at that. The way we do algebraic fractions is exactly the same way that we do normal numerical fractions. We do that common denominator, whatever you multiplied the bottom by, you do the same on the top, and then we simply add the tops. So, for the common denominator, we're going to use the combination of these two multiplied together. So that one is going to have its new denominator of x plus 1 brackets x, and this one's going to have the same. The bottom here was multiplied by x, so the top gets multiplied by the same. And the bottom here was multiplied by the brackets, so we'll multiply the top by the same. But it's only multiplied by 1, so that is simply x plus 1 on the top. And then we've got the same denominator, so we can just add the tops. We've got 4x's plus another x and a 1. So that's 5x plus 1 on the tops. We can also multiply out the bottom there just to make it look a little bit nicer. So there we go, with 5x plus 1 on the top and x squared plus x on the bottom. Right, that's part A. I'm going to wipe down the board and pop this back up at the top and then come back with part B. See you in a minute. Right, here's part B. We're told that our algebraic fraction is equal to x, and you're asked to solve that for x, leaving your answer in surd form. So have a go with that. If you are completely stuck, I'm going to come back and I'm going to give you a partial answer and then have a go again, but see if you can do it all on your own first. Right, well the first thing we're going to do is use that transformation we had in part A. So we're going to write that as 5x plus 1 over x squared plus x is equal to 7. Now that might not look like it's got any better, because here we had x in 2 places equals 7, here we've actually got x in 3 places is equal to 7. But hold on just a minute, this is going to look a lot nicer. What we're going to do is multiply by whatever's on the bottom of the fraction. The advantage here is it's one fraction instead of 2. And when we do that, it will turn into a quadratic. So what we've got over here, if we multiply by the bottom of the fraction, which is always a good thing to do, if you're not ever sure what to do, multiply by whatever's on the bottom of the fraction is quite a good ploy. 7 lots of x squared plus x. Okay, I'm going to speed up this next bit while I just kind of rearrange that so that it looks nice. Okay, so I've just expanded the brackets and then I've subtracted everything on that side from here, so I end up with 2 x's and a minus 1 equals 0. And here we have a standard format quadratic, ax squared plus bx plus c. Now, at this point we need to solve it. 3 methods. You could factorise it. It doesn't factorise. You could use the formula, which can leave you with square roots in it if you want to use that, but I'm actually going to use completing the square. We have a clue from the fact that the question says leave your answer in surd form, that's with square roots in it. That tells you it's not going to be whole numbers, so there's no point even trying to factorise it. You can use the formula as I said, but I'm just going to wipe down the board and then I'm going to solve this by completing the square, so I'll see you in a minute when I've wiped down. Right, here's our quadratic that we had, and I'm going to solve that by completing the square. Now, if you have no idea what that is, check out some of the other Batty Boffin videos where I'll go through it slowly, but here I'm just going to kind of whip through it fairly quickly. Quick little reminder though, completing the square uses the perfect square expansion. Here's a quick reminder of what it is. If we have x plus a can be any number, squared, then that expands like this. Okay, hopefully you're familiar with that. We get x squared, and then we get an ax and another ax, and then finally an a squared at the end. The point of this is that any quadratic that's in the format of x squared plus double a number x plus that number squared will be a perfect square. For example, if I have x squared plus 6x plus 9, that is x squared plus a number doubled, that number of course is 3, plus that same number squared. That is a perfect square, and that will factorise like that. Works with anything, so it's x squared plus a number doubled, x's, plus that same number squared, and it factorises into x plus that number. We're going to use that here. Now at the moment this is nothing like that format. For a start it's got a number in front of the x and we're not allowed that, so we're going to start off by dividing everything through by the coefficient of x squared. So that will give us x squared plus 2/7 x minus 1/7 equals 0. Okay, divided through by 7. Now we're nearly in this format, but we're kind of getting there. At the moment this last bit is wrong, so what I'm going to do is add it to both sides just to get rid of it. Okay, so now I've got my x squared plus double a number x's. Yep, I've got double a number x's. If 2/7 is double my number, then my number must be 1/7. So I need to have it squared at the end. So I'm just going to add it in to both sides. Don't worry about what's on the right hand side, we'll fiddle around with that later, but the left hand side is now in the correct format. X squared plus double a number, that number being 1/7, double a number x's plus that same number squared. This means that the left hand side is now in this format. Looks like this. So now we can square root it, or rather factorise it. We'll square root it in a minute. Yep, and I'm just going to expand this. 1/7 is equal to 7/49, and that's equal to 1/49. Hope you're okay with those. If you're not, check out some of the fractions ones. Gives us in total 8/49. Okay. Although this may look complicated, you will note we only have x in one place now. Okay, we've gone from a quadratic down to x in just one place. We can now square root both sides. And a little bit of surds work there, we can split that. Again, if you're not sure on that, check out the videos on surds. And then simply subtract 1/7 from both sides. Oops, don't mean 8 there. Since they're both over 7, I can combine them into 1. Okay, so that's plus or minus the square root of 8 minus 1 over 7, and you can just leave it like that. You don't need to work that out. The question said leave it in surd form, so that is the answer. It is important that you put the plus or minus in front of the 8 so that you get your 2 answers, because your quadratics have your 2 answers and that's where they come from. Okay, that was quite a doozy, wasn't it? Hope you're okay with that. I will see you in another video for a little bit more GCSE exam practice. See you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!